Hello students, I am explaining about Heisenberg uncertainty principle. Heisenberg is the name of scientist. Uncertainty means not accurate. Which one is not accurate, sir? See, definition for this. It is impossible. It is impossible to determine the exact position and momentum of an moving electron. You see, dears, if the nucleus, you feel this is the nucleus, the electron is moving like this. While the electron is moving, this moving electron having the momentum. So we can calculate the momentum of an electron, or if it is stopped at somewhat place, then we calculate the position of an electron. If we calculate the position, we cannot identify the momentum. If we are calculate the momentum, we cannot identify the position. So at a moment, spontaneous moment, we cannot identify the position, we cannot identify the momentum. Momentum and the position cannot explain at a moment. This is explained by Heisenberg. So that's why this theory is said to be Heisenberg uncertainty principle. You see this, he proposed one formula, delta x, delta p greater than or equal to h by 4/5. This is the formula is used to calculate the exact position, either exact momentum. This delta p, we can write this one as a mass into uncertainty of velocity. This delta symbol indicates uncertainty. So in the place of delta p, you may write m delta v. So delta x, m delta v is greater than or equal to h by 4/5. You may write like this. I write this formula in another form. You see, delta x. So here I written the delta v, this m bring to right side nana, h by 4/5 into m. So from this formula, you may observe, my dears, you may observe this delta x is the uncertainty of position. Delta v is the uncertainty of the velocity. Clear? These uncertainty values are directly proportional to the mass of the particle or inversely proportional to the mass of particle. See, this is inversely proportional to. So, delta x into delta v is inversely proportional to m. So, based on this, what point we are extracted? If the mass of the particle is more or size of the particle is more, this uncertainty values are less. Means we can calculate the somewhat accuracy. So mass is more, we get the accuracy values. Mass is less, we get the accuracy values. Mass is low, we cannot get the accuracy values. This is the meaning. For suppose you may take the particle, now we discussed about of the electron. Here we may take the electron. If sufficient frequency or somewhat frequency of light is applied, then this light is not reflected. This light is moving like this way only. Means these microparticles are there for suppose while the frequency of light or simply light is applied on it, it is not reflected. If the macro particles we are taken, this is the macro particle, 10 kgs or 20 kgs or somewhat big size of a stone if you are taken. If the light is applied, passed on it, then this is reflected. So the light is reflected like this means we can observe the exact the position or exact the momentum or reflection of light like this observed. If we are taking the simple particles or small particles or negligible mass of the particles if we are taken, this light is passed through the micro level of the particles only. Means this Heisenberg uncertainty principle cannot applicable for micro particles, it is applicable for macro particles. Got it, my dears? It is applicable for macro particles, this point 1. It is applicable for macro size particles. Next, the second point. According to Bohr's Nana, the electron is revolves around the nucleus in certain particular path only, like this, in a definite path only. According to the de Broglie's, the electron is revolves around the nucleus in certain particular path is possible, or it is also having the wave nature. But Heisenberg is ruled out from this. So Heisenberg principle, uncertainty principle is follows the Bohr's theory or de Broglie's theory or not follows the Bohr's theory or de Broglie's theory means it is ruled out the Bohr's theory and de Broglie's theory. This is the second point. It is ruled out the what ma? It is ruled out the Bohr's theory, mainly Bohr's theory, Bohr's and de Broglie's theory. Got it? These are the 2 points we are observed from Heisenberg uncertainty principle. And some cases are also there, Nana. I explains the cases regarding of this one, case 1 and case 2. Okay, see, case 1 and case 2. First, I feel case 1. If uncertainty of the position is 0, then what about the uncertainty of the position is 0, then what about the momentums are? You see the formula delta x into delta p is greater than or equal to h by 4 phi. This is the formula. What we feel, my dears? Delta x is equal to 0. So I written this is delta p is greater than equal to h by, you may bring this delta x value to right side. So I written 4 5 into delta x. What is the delta x value? 0. So delta p is greater than equal to h by 4 5 into 0. Got it? So delta p greater than equal to h by 4 5 into 0. So something into 0 values becomes 0. Got it? Something by 0 value is infinity. So delta p is greater than or equal to infinity. Means what, sir? Sir, what is the meaning of this one, sir? If delta x is equal to 0, uncertainty of the position is 0. So uncertainty of the position is 0 means we are calculate the accurate value of delta x. If position is identified, accurate position is identified, we cannot identify the momentum. That's the meaning. Got it? delta x is 0. So accurate position is calculated. We cannot calculate the accurate momentum. This is case 1. If case 2, you may take the case 2. If delta p is equal to 0. Okay, substitute the values, Nana. Delta x into delta p greater than or equal to h by 4/5. So delta p value is 0. So delta x greater than or equal to h by 4/5 into 0. So delta x greater than or equal to h by 4/5 into 0 value is 0. So delta x greater than or equal to h by 0 means this is infinity. Sir, what is the meaning of this one, sir? If delta p value is 0 means uncertainty of the momentum of an electron is 0 means we can calculate the accurate position of an electron. Accurate position of an electron, we cannot identify the delta x value means accurate position we cannot calculate. If you calculate the momentum of the value exactly, correctly, we cannot identify the position. Means among this delta x and delta p, if we calculate the delta x value, we cannot calculate the delta p. If we calculate the exact delta p value, we are unable to identify the delta x value. Means Heisenberg uncertainty definition only that one. If we calculate the exact position, we cannot calculate the exact momentum. If we calculate the exact momentum, we cannot calculate the exact position. Both are not calculated at a moment. Got it? This is Heisenberg uncertainty principle. This is case 1 and this is case 2. Thank you.